Looking at the homework question for level 1 from NCEA 2018, questions 1 and 2, and here's the questions over here. Now when we get one of these questions, the absolutely essential thing to do, the very first thing to do, is look at our graph and see what type of graph it is, and in this case it's a speed versus time graph. It's not distance time. Check up on it, speed versus time graph. So I've got a graph like this, and I'd just like to remind us of two things about speed time graphs. And speed and time, speed is usually going to be meters per second, it may be kilometers per hour, and time usually in seconds, but perhaps in hours. When we have a speed time graph, speed time, not distance time, speed time graph, perhaps it might look like this. When we look at this graph, there's two things which need to come to mind immediately. Number one is that the slope of the graph, is the acceleration. So when we look at this graph, there's three sections to it. Section 1, section 2, and section 3. When we look at our graph, we can see the slope of this first section is this amount divided by this amount, so it will equal this change, which is a change of velocity, divided by this change of time, and we'll say the acceleration is equal to the change in speed divided by the change in time. This distance divided by this is how we measure the slope. So it's going to be meters per second divided by seconds, so it's going to be in meters per second squared. And when we look at this graph, we can see that at this point, section 2, the slope is 0. There's no acceleration from this point to this point, from this time to this time, so this one has got no acceleration. When we look at this third section, we can see its slope is greater than the slope in the first section, so the acceleration in this section is greater than the acceleration at that point. That's the first point. The slope of the graph, when we work it out, is equal to the acceleration on a speed time graph. The second thing which stands out is the area under this graph. When we look at this graph here, if we can calculate this area, the area is equal to the distance the object has traveled. The area under equals the distance the object's traveled. Now it's not easy to work out the area of this large shape here, the strange shape here. So what we do is we divide it up into different sections. So this first section is a triangle, and we'll calculate the area of this triangle, and the area of that triangle is equal to our formula 1/2 times the base times the height. 1/2 this length, the base, times this length, the height, is the area of that triangle. The second area, number 2, we can calculate this area more easily. This area is equal to the base times the height, whatever this base number is here times that height. And again, coming around to this third area with this four-sided shape, how do we calculate the area of this shape? Usually we do it by dividing it into two shapes. A triangle here, whose area is again 1/2 times the base times the height, plus this area, this rectangular area, whose area is equal to the base times the height, and we add these two together. The area of this shape is equal to the area of this triangle plus the area of this rectangle. So those are the two things we need to remember, that the area is equal to the area under the graph. Area under the graph is equal to the distance that the object has traveled. So we'll need this to be able to answer our questions from our paper today. So let's look at our question. The speed time graph shows the motion of two runners in a 100-meter race. First thing, make sure we look and see what type of graph it is. It's a speed time graph. It's speed time. I can't emphasize that enough. If we confuse it with a distance time graph, we're going to get the wrong answer from the very beginning. So here's a speed time graph, and there's two runners in here. Let's have a look at a larger version of this. We've got two runners. The bold line is runner A and the dotted line is runner B. And our first question, from the graph, which runner has the greater acceleration in the first 3 seconds? Which runner has the greater acceleration in the first 3 seconds? Let's have a look where the first 3 seconds are. 2, 4, 3, right in the middle there, 3 seconds. Which runner, the bold line of runner A or the dotted line of runner B, which one has the greater acceleration? We just need to remind ourselves that acceleration is equal to the slope or the gradient of the line. So which one of these has got the greater slope? Is it runner A or is it runner B? Clearly runner A has the greater slope, and we will write runner A has the greater acceleration because it's his or her slope. Her slope is greater than runner B's slope. Okay. Calculations not required. Question 2. Using the graph, calculate runner A's acceleration during the first 3 seconds. Calculate runner A's acceleration in the first 3 seconds. Runner A is the bold line, and the acceleration equals the slope of the line. So how do we work out the slope of this line? We work it out by finding this change, which in this case is a change of speed going from 0 to 9. We work out this change, the change of speed, delta change, divided by this distance here, this here, which is a change of time. And the slope equals the change in speed divided by the change in time. The way we calculate slope is we do the y change over the x change, the y change over the x change. So we've got a change of velocity, delta v over delta t. So we'll write acceleration is equal to delta v over delta t. In this case, the change in speed goes from 0 up to 9. So the change of speed is 9 meters per second. And the time taken is 3 seconds. So the acceleration is 9 divided by 3 is equal to 3. And the acceleration meters per second squared. So make sure you get your units in there as well. That's 1b. C part 1. Use the information in the graph to compare the speed and acceleration of runner A and runner B in the first 10 seconds. So we need to compare the speed and acceleration of runner A with runner B in the first 10 seconds. So we're only going up to here. So let's look at runner A. Runner A increases his velocity from 0 up to 7.5 meters per second in the first 3 seconds. So his acceleration is equal to Runner A increases his velocity from 0 up to 9 meters per second in the first 3 seconds. So his acceleration is 3 meters per second squared. And then from 3 seconds through to 10 seconds continues at a constant velocity of 9 meters per second. And we will write that down as we go along, fill this out. Runner B increases speed from 0 up to 10 meters per second in 4 seconds, so runner B has got an acceleration of 2.5 meters per second squared. And then from 4 seconds through to 10 seconds runs at a constant speed of 10 meters per second. So that's a comparison of the acceleration and speed of A and B. Part 2. Use the information in the graph and calculate to show which runner, A or B, finishes the 100 meters first. Who wins the 100 meters first? Now to do this, we'll need to calculate the area under the graph. In order to see who came first, we need to see who gets to 100 meters first. And remember, when we're looking at a speed time graph, it's the area under the graph which gives us our distance. So we're going to now look at this graph and see how far they went in 12 seconds. So let's see how far they ran in that first 12 seconds. Let's look at runner A. How far did they run in 12 seconds? We need to calculate that for runner A, the area under this graph. If we can work out the area under this graph, it will give us how far runner A has run in the 12 seconds. In order to do this, again, we'll divide it up into these 3 areas. Area A, area B, and area C. To calculate the area, let's bring this over here, this area A area equals a half the base times the height equals 1/2. The base is 3, the height is 9, equals 13.5, and it's a meters per second versus seconds. This is going to be meters. Let's work out the area of this section B. So this is area A. Area B is equal to the base times the height. The base, and you need to make sure that we don't say the base is length 10. The base is actually from 3 to 7. So the base is 7 times a height of 9 times 9 equals 63. Now the area of this third section, the area under this graph, we're going to do the area of this triangle plus the area of this rectangle. So the area of the triangle, a half times the base times the height, is equal to a half times the base. It's going from 10 to 12 seconds is 2 seconds times 2 times the height. It's going from 9 to 11. It's a difference of 2 times 2 is equal to 2. Remember, these are distances in meters. This area is 2, so we've got an area of 13.5, 63, 2, and the area of this rectangle here is base times height. the base of 2 times height of 9 is equal to 18. So we need to add these 4 together, and if we add these 4 together we get an area of 96.5 meters. So in 12 seconds runner A has travelled 96.5 meters. Let's then have a look at runner B, and I'm going to do it in full just so we can make sure we've got this right. Runner B, what's the area under the graph for runner B in 12 seconds? Here's runner B's graph, and we need to calculate this area, this whole area. So let's divide it up again into triangles and rectangles. Area A, B, and C. The area of triangle A, 1/2 times base times height. The base is 4 equals 1/2 times 4 times a height of 10 is equal to 20 meters. The area under this graph here is 20 meters. So in the first 4 seconds runner B will have travelled 20 meters. Between 4 and 10 seconds the area is base times height, which is equal to, again, from 4 to 10 is 6 times a height of 10 is equal to 60 meters. So between 4 and 10 seconds it's gone 60 meters. This area C, let's divide into 2 parts again. The area of this top half, 1/2 times base times height is equal to 1/2 times the base, 2 seconds, times the height of 2 seconds is equal to 2 meters. The area of this rectangle now, base times height, is equal to base 2 times a height of 10 is equal to 20. Now let's add them all up together and we get 22, 82, 102 meters. So after 12 seconds runner A has run just 96.5 meters, whereas runner B has run 102 meters. Runner B is the winner. So question is, use the information to calculate which runner has finished 100 meters first. Clearly it's runner B. Question 1D. Using the information, that's question 1D. Each of runner A's feet, that's his feet, you can see his toes, and this little piggy, we should be like this one and stay home. Remember, we're still under level 3. This little piggy went to market, this little piggy stayed home. That's what we should be doing. Okay, each of runner A's feet has a surface area of 0.2 meters per second squared. So the area of his feet, the area equals 0.02 meters squared area, which sink into the track. Together the feet exert a pressure of 13,000 pascals. Calculate the weight of runner A. Calculate the weight of runner A. Remember our formula, pressure equals the force applied divided by the area. We might write P equals F over A. So let's substitute in our, let's rearrange our equation. Pressure is force over area, therefore force is equal to pressure times area. And let's substitute our value in. The pressure is equal to 13,000 pascals, and the area is tricky because this is the area of 1 foot, but normally our athletes will have 2 feet. So if this is the area of 1 foot, the area of 2 feet has got to be double. So pressure is equal, force is equal to pressure times area, 13,000 times 0.0400. So the force is equal to 520 newtons. And make really sure that when you answer questions like this again that you include the units. So that's question 2. So that's our assignment for this week. Actually, when I say that's our questions for this week, what I mean is that we need to do question 2A. Willow and a mountain bike have a combined mass of 82 kilograms. Here's Willow on her bike. Willow on a bike, they've got a combined mass of 82 kilograms, and she accelerates at the start of a race at 0.80 meters per second squared. Question A, calculate the net force acting on the bike and rider when accelerating. Combine the net force. Now we can go straight to our equation. Remember our equation, F is equal to mass times acceleration. We want to calculate the force. So it's equal to mass 82 times 0.8. So the answer is equal to 82 times 0.8 is equal to 65.6. And remember force is in Newton, 65.6 Newton. We're not going to make a big deal of it at the moment, but in it, her mass, she's given a mass that has 2 significant figures, and her acceleration is given 2 significant figures. So the answer must be in 2 significant figures. So that we're going to rewrite that as not 65.6, but we're going to write it as 66 newtons. So in either of those answers will probably get you the right answer. Thanks then.